Hello, yo, welcome back. All right, so we're still on Projectile, and here we're going to be looking at some um, questions, some example. All right, so I have the very first question here on the screen. A ball is projected at an angle of 30 degrees to the horizontal. If it is thrown with a velocity of 20 meters per second, calculate the time of flight. So all we just need to do is to apply the different formula of projectile that we have already derived. Okay, starting with the A part of the question. So we're looking for the time to reach the maximum height. At the time of flight, please pardon me. Remember, the time of flight is always 2 times the time to reach the maximum height, which of course is 2 times u sine theta, then of course divided by g. So this is going to be 2 times our u from the question is 20. Then sine theta, the angle of projection is 30 degrees. Then divided by g, which we are going to use an approximate value of 10. All right, so 2 times 20 is 40. Sine 30 is 0 0.5, then divided by time. 20 times 0 0.5 times 40 is 20. Then 20 divided by 10 is 2, so 2 seconds. 2 seconds is the answer for A part of the question. So B, we are looking at the maximum height. Don't forget the formula for maximum height. The maximum height attained by the projectile is u square, the sine square theta, then divided by 2g. So what do we do in this case? So u of course is 20, so that's going to be 20 square. Then sine square theta. Sine square theta is something as sine theta all square. Sine theta is 30. Alright, then all is squared. Then divided by 2 times g. That is 2 times 10. 20 square is 400. Alright, 20 square is 400. And if we do 0. Sine theta is 0.5. 0.5 square is going to be 0.25. Alright, then 2 times 10 is 20. So let's do that multiplication. So I'll end up having okay, so when I multiply, I'm going to multiply 400 by 0.25, then I divide it by 20. Alright, so let's do that. 400 alright, 400 multiply by 0.25, then divided by 20. That's 5. So we are looking at 5 meter. So the maximum height of that projectile is 5 meter. Then the last but not the least is the range. The range of the projectile, which of course is given by the formula u square sine 2 theta, then divided by g. Of course, u is 20. 20 square sine 2 times theta, that's sine 2 times 30, then divided by 10. Okay, if we do this, it's gonna be 400. 2 times 30 is 60 sine 60, then divided by 10. Alright, so here we go. So this is going to be equal to sine 60 okay, sine 60 is 0 0.887 approximately times 400, then divided by 10. Okay, so that is 34.8. So the range is 34.8, and that is in meter. So I hope that is well understood. That's another form of question you'll be asked. All right. Now this type of question goes this way. So the question is, at what angle, theta will the projectile be projected in order to have the range equal to, in order to have a range twice the maximum height? At what angle would the projectile be projected to have a range twice the maximum height? Okay, so solution. So to write that, of course, in mathematical formula, we are looking for the angle that will make the range to be equal to 2h. How can we actually use this to solve for theta? So we actually insert the expression for range, which of course is u square sine u square, right? Sine 2 theta, then divided by 2g. Divided by g, please pardon me, not 2g. Alright, so we also insert the expression for the maximum height, which of course is this is going to be 2 times the maximum height is giving us u square sine square theta, then all over 2g. So the whole idea is to actually rearrange this expression to just solve for this angle right here, theta, the angle theta. All we just need to do is start cancelling the same factor that is found at the same position, both sides of the equation. G is found at the denominator, then G is also found at the denominator on the other side, so it's I take it out. Okay, so there's another thing that I need to cancel. What of u square is found at this side, this u square is found at the other side also at the same numerator. So I'm left with the sine of 2 theta. Of course, 2 can also divide 2. 2 is gone. So I'm left with just sine of 2 theta is equal to the sine square of theta. So how do we actually solve this? You arrange this so that we can make theta the subject. What I can do is I'm going to change this to the original expression, which of course you know very well that sine 2 theta is the same as 2 sine theta, then cos theta. From advanced trigonometrical ratio, that's what it means. So it's equal to sine square theta. So what do I do in this case? What I can do, I'm going to rearrange this equation so that I will have the constant, this coefficient to be at one side, then all the ratios to be at the other side. So I will, okay, so I would rather have sine square theta, okay, being divided by sine theta cos theta, all right, at one side of the equation. So it's going to be 2 is equal to sine square theta, then all divided by sine theta, then cos theta. So what is going on here? What is going to happen? Sine theta divide itself 1, then divide sine square theta. I'm just left with sine theta. All right. So invariably now, one side of the equation is only, I'm left with sine theta cos theta. Okay, sine theta all over cos theta is equal to 2. And there's another trigonometrical, all right, identity for this. Sine theta all over cos theta is tan theta. Sine theta all over cos theta is tan theta. So tan theta is equal to 2. So that way we can find theta. So theta is actually solved by evaluating the tan inverse of 2. Okay, let me see if my scientific calculator will have, if my calculator have the scientific. Okay, so let me change this to scientific calculator so I can find the inverse of tan of 2. Okay, so I'll go do second shift, do inverse of tan of 2. Okay, so let's do this. So I'll do this shift, inverse of tan, so that's going to be 63.4 approximately. So the angle theta that we're looking at is 63.4 degrees. So I hope that is well understood. So um, basically in projectile, the only difference between projectile and the other motion under gravity is just this attachment of the sine of theta, because a projectile is a motion of an object in an angular path, so there's always angle. So adding this, including this angle, all right, the ratio of this angle is what actually makes the motion of a projectile different from the motion of object under the influence of gravity. All right, so that is it for this video. We are going to look at more in the next video. So see you in the next video. Thank you very much.